The level 2 type problem is much more accurate in terms of describing what could really go on. So in this one, what we have are things you could do in the lab. Mixing different volumes of different concentrations together and determining whether or not a precipitate forms. Right? So an important first step is identifying what are the reacting ions. Right? Lead ions up here and chloride ions. So we identify what are the ions participating in the precipitation that could possibly happen. And it's important because we need to know that there's a 2 in front of the chloride so that we come up with the right expression that has a 2 exponent up here. The trick in this one is that the initial concentrations are not the concentrations that result when you mix the two together. So we have to determine for each of these ions their concentration after you mix them. The way we do this is we pretend that we have this moment in time when we can capture them when they're mixed, but before they react. So if I take my concentration of lead at the start times its volume divided by the total volume, and that's what this is down here. This is total volume down here. Then I can find before any reaction happens what the concentration of lead is. I am checking to make sure that my source of lead is only giving me one ion for every molecule, and it is. There's one lead. When this splits up, I'll have the same concentration of lead ions as I do of the entire molecule. I do the same thing with the salt, just substituting for the chloride its original concentration and its original volume. Everything in this will have the same total volume. So now I have two concentrations after they are mixed but before they react. So I have the concentrations that I can now plug into my Ksp expression. So it's suddenly all the way back to level 1. I have the concentrations in the Ksp expression. I substitute in, making sure that I'm including my squared term, and I find my Q. I've compared Q to Ksp. This time it is less than Ksp, so no precipitate forms.